In this video, I will cover the properties of Z transforms. Right, the first property we have linearity. The linearity property says x1 of n whose Z transform is x1 of Z, x2 of n whose Z transform is x2 of Z, a into x1 of n plus b into x2 of n whose Z transform is a into x1 of Z plus b into x2 of Z. This is the linearity property. Second property we have time shift. X of n whose Z transform is how much? X of Z. X of n minus 1 shift in time for discrete time m times. Then whose Z transform is Z power minus m into x of Z. X of n plus m whose Z transform is Z power m into x of Z. This is the time shift property. Third one, multiplication by exponent. Multiplication by exponential. Now you can observe x of n whose Z transform is x of Z. Now let us multiply with an exponential. A power n x of n whose Z transform is x of Z by a. This is one exponential. And let us go with one more exponential. E power j omega n x of n whose Z transform is x of Z by e power j omega. E power minus j omega n into x of n whose Z transform, I am writing Z transform, is x of Z by e power minus j omega. Right? This is the multiplication by exponent property. Next one will have reversal. So property number 4, reversal. X of n whose Z transform is x of Z. X of minus n whose Z transform is x of Z inverse, that is 1 by Z. Okay, this is the time reversal property. Fifth one we have time expansion property. X of n whose Z transform is x of Z. Now time expansion, expanding time. X of n by k whose Z transform is x of Z power k. This is the time expansion property. Right? Next one, differentiation in Z domain. This is also called as multiplication by n in time domain. In time domain, right? X of n whose Z transform is x of Z. N into x of n whose Z transform is how much? That is minus 1 power 1 Z power 1 d power 1 by dz power 1 into x of Z. Similarly for n times, n power k x of n whose Z transform is minus 1 power k z power k d power k dz power k into x of z. This is the differentiation in z domain property. Right, and next one, conjugate property. Seventh one we have conjugate property. The conjugate property is nothing but x of n whose z transform is x of z. X star of n whose z transform is x star of z star is a conjugate property. And next one we have Parseval's property. Parseval's property. We can observe the Parseval's property. Sigma n equal to minus infinity to infinity in time domain, two signals x1 of n, x2 star of n, let it be, which is equal to in frequency domain 1 by 2 pi j closed integral of, so this can be written as x1 of z into x2 star of z star whole inverse into z inverse dz. Right, this is the Parseval's theorem. Now, next we'll go to the next property, which is convolution property in Z transform. If two signals x1 of n is convolved with x2 of n, they are going to be multiplied in frequency domain. This is the convolution property. And next we have very important thing, initial and final value theorems. Then one we have initial value theorem, and next one we have final value theorem. Initial and final value theorems. Let us observe the initial and final value theorems. So the initial value is nothing but x naught, right? Which is equal to, x naught is equal to limit n tends to 0 x of n, means n is 0 means x naught. As n tends to 0, that tends to infinity into x of z. This is the initial value theorem. Coming to the next theorem, we have final value theorem. This final value theorem I'll write here. Final value theorem. So the final value is nothing but x of infinity. X of infinity can be written as limit n tends to infinity x of n, which is equal to limit z tends to 1 minus z inverse into x of z. This is the final value theorem. This initial value theorem and final value theorem are very important in the gate point of view. So these are the properties of Z transforms.